Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I'm Arif and I welcome you all to the next session of the lecture series on Internet Working with Linux. In the previous session of Apache web server using HTTP, we observed that all the data is transmitted in plain text and anyone can eavesdrop and see that data. Under normal circumstances, if you are watching a stupid video like this one, just joking, or maybe if you are googling the solution of an assignment, you really don't care for the security part. However, if you are doing some banking transaction, or if you are buying something on the internet via your credit card, or maybe if you are logging into your email server by entering your username and password, then all this information must be protected and encrypted. So to ensure security, we need to use HTTPS instead of HTTP. HTTPS, that is HTTP over SSL, provides data confidentiality that is achieved using encryption, data integrity that is achieved using hashing and digital signatures, and client and server authentication that is achieved using digital certificates. Before we move on and configure our Apache web server to work with SSL, let us brush up these concepts first. Well, dear students, in our cryptography sessions, we have discussed the three goals of security, that is the CIA paradigm, where C stands for confidentiality, I stands for integrity, and A stands for availability. Well, so far, a non-availability of a resource is not our concern. Our primary concern is achieving confidentiality and integrity of data that we send over the unsecure internet. As far as confidentiality is concerned, we want to ensure that no man in the middle should be able to snoop or intercept our data for reading the confidential information or to carry out any sort of traffic analysis. We have discussed the use of various ciphers, both symmetric as well as asymmetric, to achieve confidentiality. The other goal is achieving or ensuring integrity of data. That means the data can only be changed by authorized entities and through authorized mechanisms. We want to ensure that no man in the middle should be able to launch attacks like modification, that is intercepting and modifying the information during transit, masquerading or spoofing, in which the attacker impersonates somebody else, and repudiation, that is the sender himself denies that he or she has not sent the message, or maybe the receiver denies that he or she has received the message. We ensure integrity using digital signatures and digital certificates. In our previous sessions, we used digital signatures in which the sender signs the hash of the plain text message with his or her private key, and later the receiver verifies the signatures using the sender's public key. Well, verifying the digital signature on the receiver sides give the surety that the data has not been changed during transit, thus giving security against all sort of modification attacks. Well, dear students, digital signatures also give security against all sorts of masquerading attacks, as only the sender has his private key which is used to generate the digital signature. However, digital signatures do not ensure known repudiation. That is, the sender can still deny that he has sent the message. Although the receiver has the public key of the sender using which he has verified the signature, but the sender may later change his private public key pair and can say that this is not my public key. Well, the solution to this problem is digital certificate. Digital certificates are issued by trusted third parties called the CAs or certification authorities. Some famous CAs are Symantec, GoDaddy, and GlobalSign. Let us try to understand the procedure of how a digital certificate works. You get a digital certificate from a certificate issuing authority, which along with other information contains your public key. The CA or validation authority records your public key with them for later validation purpose. The CA or the certification authority also signs every digital certificate that they issue with their private key. And this is to prevent the certificate from being forged, and of course for verification of that certificate using the public key of the CA. Once you have got your digital certificate, you can make it public, and anyone can download your digital certificate, can verify its validity using CA's private key, and can extract your public key from it. Now you cannot say that this is not your public key due to the involvement of the trusted third party. So this is how digital certificates ensure repudiation, rather known repudiation. Okay, dear students, this was a summary of what we learned and practiced in our 2 sessions of cryptography. If this sounds Greek to you, please make time to view and practice the sessions on cryptography. And let us now move ahead and make our hands dirty on a Linux terminal and configure our Apache web server to work over SSL or TLS. Right now I'm on my Ubuntu server machine, and the IP is the same 192.168.1.100. Let me check the status of Apache 2, which is of course running because we enabled it in our previous session. And let me move to var www HTML directory, that is the default document root directory. And if I see the listing of this directory, you can see arifbut1.com, arifbut2.com, which are the 2 websites we created and we hosted them in the previous session. Let us create and host another website, arifbut3.com, in the same fashion, and make it secure using SSL. To save time, let us just make a copy of the existing website by cp-r arifbut2.com to arifbut3.com. Now we have a directory arifbut3.com. Let me move to this directory. You can see the same 2 files, index.html and process.php. Let me cat index.html. Well, we created this file in the previous session, which displays a form, and once the client requests this form, it is displayed on the client browser. It is used to get the username and the password from user and submit the 2 values via the HTTP post method to process.php file. And let me do cat process.php as well. This file receives the 2 values, and after comparing them with the actual username kakamana and password PUCIT, send them either a welcome or a sorry message to the client browser. Well, I have discussed the code of these 2 files in a previous session, so I don't think that there is a need to do it again. Let's move ahead. Since we want this website, that is arifbut3.com, to be accessed via HTTPS, So we need to enable the Ssl module for our Apache web server. Let me move to the Apache 2 directory, /c Apache 2. Let me see the long listing. Well, over here you can see two directories, modes available and modes enabled. The modes available directory contains configuration files related to all available modules. Let me do ls modes available. So there are a lot of modules over here. Let me clear screen. I just want to check the modules related with SSL. Well, there are two files in modes available directory. One is ssl.conf and the other is ssl.load. ssl.conf is a configuration file for SSL module. You can change the settings, but right now let's keep moving with the default values. And the ssl.load, this file is there in modes available. Well, this ssl.load file, this contains the path of the shared object file that will be loaded once we load SSL for our Apache web server. So let us enable the SSL module for our Apache web server. Before I do that, let me do again modes enable. Let's see the long listing of modes enabled. You cannot see these two files over here in this directory, ssl.conf and ssl.load. So these are the soft links to the files in the modes available directory. Let me use the command a2en mode, that is enable mode SSL. It has been enabled. Let me check again now the listing of modes enabled directory, and you can see ssl.conf and ssl.load file over there. Well, dear students, you can always disable it using a2dismode command. Let me show this as well. Right now modes enabled contain ssl.conf and ssl.load file. Let me do a2dismode SSL, and let me again check. You do not see the soft links of ssl.conf and ssl.load over here. Let me do again a2en mode SSL, and now if I do the listing of modes enabled, you can again see ssl.conf and ssl.load over there. Well, to activate the new configuration, let us restart the Apache service. systemctl restart Apache 2.service. Okay, now the next step we need to do is we need to create a digital certificate for our website arifpart3.com. It will always be better if you can get a digital certificate from a trusted third party like Symantec or GoDaddy. But if you do not have dollars in your pocket, or if you're doing this just for learning purpose, a self-signed digital certificate will do the job. Let me clear screen and use the command openSSL that we have used in our previous sessions as well, and give the subcommand req, which is a subcommand to SSL used to generate a self-signed digital certificate. Give the option -x509. X.509 is a standard that describes a certificate in a structured way. The option no DES, which tell SSL that we do not want to secure our private key file with a passphrase. And then -days 365, that is the validity period of the certificate. -new key RSA 2048, and this option is used to create a new private key based on RSA algorithm with a key size of 2048 bits. And finally, let me use the keyout option and give the path @C Apache 2 SSL Arif but 3.com.key @C Apache 2 SSL Arif but 3.com.key. Well, this is the file which will contain the private key for the public key in the certificate, and I have mentioned the absolute path where this file will be saved. Let us use the out option and let me give @C Apache 2 SSL Arif but 3.com.crt. Well, this is the name of the file which will contain the digital certificate. Once I press enter, it will ask me some questions. Let me answer them. The country name is PK. The province is Punjab. The locality is Lahore. Organization name is Punjab University. The organizational unit is PUCIT. The name of the server is www.arifbut3.com. So this is the name of the website we want to secure. And let me give my actual email address, arif@pucit.edu.pk. Okay, we are done. Let me move on to the SSL directory. Right now, I am in @C Apache 2 SSL directory, and this directory now contains arifbut3.com.crt, the file which contains the digital certificate, and arifbut3.com.key, which contains my private key. Okay, let's view the contents of this file using again OpenSSL pkey in arifbut3.com.key. So this is the private key in base64 format. Okay, let me clear screen and let me use the hyphen text option and pipe it to less, so you can see the base64 key and the detailed contents, which contain first the modulus, that is achieved by multiplying two large prime numbers. Then we have the public and the private exponent, the two large primes, prime 1 and prime 2, the two corresponding exponents, and finally you can see the coefficient as well. Let me repeat the same command and see the contents of my digital certificate. Open SSL x509, which is a sub command, hyphen in arifbut3.com.crt, and I want to see the details. Okay, so this is the certificate. And the contents of our digital certificate, you can see the version, the serial number, the signature algo, validity period, name of the certificate holder, his public key, and information about the certificate issuing authority as well. Okay, so let us move ahead. What all we have done up till now is we have created and uploaded our website on Apache web server in var www.html arifbut3.com directory. We have activated rather the SSL module in our Apache web server in the @C Apache 2 modes enable and modes available directory. And we have also created a self-signed digital certificate for our website arifbut3.com and have placed it in this directory @C Apache 2 SSL. Well, next step is to create the virtual host file in sites available directory. Let me move on to @C Apache 2 directory. Let me ls Now you see we have done this before as well in the sites available and sites enabled directory. Let me do ls with sites available directory. You can see arifbut1.com and arifbut2.com.com files which we have created using the 000 default.com file. Because that contains the basic configuration for using with HTTP. But now since arifbut3.com will be using SSL, so we will use the base file as default ssl.conf. So let me copy this. Copy cp default. Okay. Let me move to sites available directory so that I can use relative path. Okay. cp default -ssl.conf to arifbut3.com.conf. Okay. So right now the sites available directory has our required virtual host file. Let me make certain changes in that. Let me use arifbut3.com.conf, open it in Vim, and you can see over here the virtual host default 443. This is the port on which this server will listen because it is HTTPS. Server admin, let me change this address to admin@arifbut3.com, admin@arifbut3.com, and let me add the server name as www.arifbut3.com. Let me add the server alias as well. Let me correct the spelling, SERVER. Server alias is, let's suppose, just arifbut3.com. And let me add document root and add arifbut3.com. So that is var www.html arifbut3.com. This is the default document root directory for our website. So I think these 4 lines will suffice. Yes, over here we have SSL engine on because we need to enable SSL for this host, so let it be on. And finally over here we need to give the path of the SSL certificate file. Let me change this to the path of @c Apache 2 SSL arifbut3.com.crt. So this is a certificate file. So we keep arifbut3.com.crt over here. And for SSL certificate key file, we mention the path of the private key file arifbut3.com.key @c Apache 2. Let me correct the spellings. Apache 2 SSL arifbut3.com.key. So that is all which we want to do. Let me save and exit this file. Clear screen. Okay, now we have made certain changes, and next thing is the file is there over here, but the file is not there in sites enabled. So we need to create a soft link in the sites enabled directory of arifbut3.com.conf. For that we use the command a2 nsite arifbut3.com.conf. Let me check out. There should not be any typo. arifbut3.com.conf, and nsite we have a single n in this. Okay, let me do again ls sites enabled. You can see arifbut3.com.conf link is there. Okay, now let's restart the service. systemctl restart Apache 2.service. Okay, it is running now. Let me check out netstat -ant grep 443. So we have a listing at 443, and let's check out on AT as well, and we are having our Apache web server listing on both port 80 as well as on port 443. Okay, so I think that is what we need to do on the Apache web server side. Let's move on to the Kali machine, our client machine, and let me open a new tab in a browser. http:// let me access the same old website arifpart2.com which we created in the previous session. Well, it is working, it's fine. And let me try to access this HTTPS arifpart3.com. remember, I'm using HTTPS this time. Okay, once I press enter, it says server not found. So probably, what is the issue? Yes, the issue is that arifpart3.com is not there in the file etc host. So we need to put an entry of this over here. So 192.168.1.100 is the IP of the Ubuntu server, having aliases arifpart1.com, arifpart2.com, and let me add arifpart3.com as well. Let me save and exit, and let me come back over here, refresh the page. Okay, so once I refresh the page, it says your connection is not secure. arifpart3.com uses an invalid security certificate. The certificate is not trusted because it is self-signed, and blah blah blah. Okay, actually what is happening is that when our browser has initiated the HTTPS session with the web server and requested the index.html file of arifpart3.com, the web server has first sent the arifpart3.com.crt file, that is the certificate, to the browser. The browser has received the certificate. It has checked it in its own repository. Where is the repository of this browser? Firefox, if I'm not wrong, it says it somewhere in USR share CA certificates. Yes, and inside this we have Mozilla. Okay, let me do ls. Okay, so well, dear students, let me move up. Okay, a lot of certificates are there with this browser. Okay, so on a Kali machine at USR share CA certificate Mozilla, these are the certificates of various web servers that are there with this browser. And of course, this list do not contain arifpart3.com.crt file. Let me clear screen and grab arifpart3.com.crt. So this file is not there. So since this browser is not seeing this file in the repository already, it has done one more step. It has tried to access some validation authority and try to verify the certificate. But since the certificate is self-signed, so the browser could not verify it. And that is why the browser has shown this message to you. Let's click this add exception button. Once we add exception, you can see that says the certificate status. The site attempts to identify itself with an invalid information. Let's view the certificate. If I click this view button, you can see this has been issued to arif3.com, Punjab University PUCIT, and the serial number is this, and issued by the same person. So this is self-signed. This is a period of validity, fingerprints. If we click the details, you can see the version, the serial number, the signature algorithm, the validity, and a lot of information is there. Anyway, so if I keep this checkbox selected, this certificate will be added to USR share CA certificate Mozilla directory, and we will not be prompted again for this. But if I keep it unchecked and click this confirm security exception, the page is now displayed to you. Let me write down the username and the password, and let me click login. You see the welcome screen. Moreover, you can see a green lock sign over here in the address bar, which says that all the data that is transmitted to and from the server are now properly encrypted over the SSL layer. Well, dear students, please do use our favorite packet sniffer, Wireshark, to verify that all the data that is sent or received now is fully encrypted. And no man in the middle can snoop your username and password during transit. As we have seen, this was happening in our previous session when we were using Apache web server over HTTP. I'm leaving this as an assignment. I hope you will be able to do that. Well, I think that is all for today's session. I hope it was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. Happy learning, and Allah Hafiz.